Hi, welcome to Coding Thursday with Fixit Gateway Security. Last week, we discussed a few fundamentals you should know in C. These fundamentals define few backslash codes, different headers, and how to specify them in your code files, the various data types such as primitive data type, derived data types, and their value range in both 16 bits and 32 bits computer. We further demonstrated a few of these codes with examples, and we also promised to create a comprehensive cheat sheet of the different header types, which we will be distributing in our Discord channel to all members of Fixit Gateway Security. And this cheat sheet, we'll be working on it soon, and probably by the end of next month, it should be ready. On this week's episode, we'll be writing a few codes in C and also describing the various arithmetic types in C programming, while breaking it down to even the simplest forms that will enable passionate programmers who want to understand the fundamentals or the skills in breaking down these methods on how to write their codes to the simplest form that is readable. So without wasting much of your time, let's begin. Arithmetic operations. In C programming, arithmetic operators describe both the logical and relational operations which the program or code is required to perform. And these arithmetical operators are categorized into three. They are unary, binary, and ternary. The unary is also known as single operator, and this form of arithmetic operations will be demonstrated further in various codes in the future when we'll be describing how to increment values, how to decrement values, how to add additional numbers to an existing values, increment types whereby you receive a range of values from a user, then you increment it by the number you desire using the increment unary operator, or you decrease the same value using the decrement unary operator to decrease this value to your own specified number, which you will be supplying to the code. The second part of the arithmetic operator is the binary. So binary basically has to do with arithmetic operations such as addition, subtraction, multiplication, division, and the modulus. So modulus is to divide numbers and retain the remainder values. And this also will be demonstrating also further in the future when we have a series of operations we want our code to perform. Ternary operations, on the other hand, or ternary arithmetic operators, are conditions that are needed to be satisfied, comparing two values, with one of these values being true and the other value being false. Example of how these values are compared is the expression 1 would have to satisfy a given condition and compare that to the expression 2, then whatever output is designated to the various expression will be printed. So for example, if expression 1 is greater than expression 2, then let the value be true. Or if expression 1 is less than expression 2, let the value be false. So this comparison is dependent on what you want your code to print out or what you want your code to execute. And as we continue posting this free content, we'll be demonstrating this in the future. So let's just write a few short code by firing up our code blocks. We click on workspace, we click on file, new project, we select console application, and we click go, and we click next. We are still talking about C, so we click next. Let's just call this lab episode 5. 05, and we click next, and we ensure that we have the GNU GCC compiler installed on our computer if you are using Windows. But if you're using Mac, probably you wouldn't be needing these code blocks, since you would be using Xcode, which is a C and C++ code editor with the functionality of compiling and outputting the compilations of your code on your Mac computer. So we click finish, then we go down to sources and we click on main file. So remember last week when we discussed the various headers, we specified that for you to be able to run your program and execute it smoothly, you have to include the stdio header, which is responsible for the input and output of the program codes in C programming. And we demonstrated a few print statements on how you can print information and a few shortcodes or backslash code in C. So having described this, let's write a new program. Let's say we want to create a variable name known as fixit. And we want this variable name to be an integer type value. And we terminate the program with a semicolon. Next, we want to create a variable which is accepting a double value data type from a user. So let's call it lab05. So now in C programming, to be able to read values from users, we have to use the scanf. The scanf in C programming is used to read numbers, characters, values, digits, and other form of inputs from users in a C program. And when we want to read those values from the user, we have to specify the data type. These data types are known as specifiers. For example, to read an integer data type, from users, we have to specify %d as the specifier, and to read float from a user or float value from a user in C, we have to specify %f. And for double, all values that are double data type in nature, we can then use %lf to read these double data type values. So let's now print. Okay. So now we have gotten this out of the way. Let's now print this program to accept values from users and output these values to the program interface. So first, to read, we'll say print f. Please kindly enter your number ensure it is integer data type /t. Then we terminate the program with a semicolon. Now to read this data from the user, which the user is going to supply, we'll say scanf. Then we'll say, now for the first number, which we have stated is an integer, we have to say %d as the specifier for integer, and we give a comma. Then we specify the end and the fixed variable name. Now what this end does is that it is instructing the program to receive this number from the user when this program executes and look for the address that has this variable name and store that number in that address. So basically, when you create a program or code by specifying the variable name and initializing the data type, the program automatically creates or allocates a memory to that variable name with that data type value. So on the computer right now, it has created an allocation for fixed, and it tells on that memory location and saying that fixed is storing an integer value data type. So whenever this user supplies any number that has to do with fixed and it's an integer value, that number will be stored in that memory location or memory allocated. So next we say printf to read the second value from the user, right? We can say please specify the second number and ensure it is a double data type value, and we'll say /t just for spacing before accepting the value, and we terminate the program with a semicolon. Now let's put a /n here to make our program more beautiful, and let's put this /n just to make our program more beautiful. Now since we are instructing the program to accept a double data type of value, then we can say scanf, and instead of saying %d, we would say %lf, which is for double. Then we give comma and we say end lab 05, and we terminate it with a semicolon. So what we're trying to tell this program as well is that please, when this user supplies this number and it's a double type of data value, look for the computer that has this variable name and store the number to the address that is allocated to this variable name. And on that memory allocation, the memory allocation that will be allocated to that variable name will be based on double. So if you supply anything that is outside double to this code, it's going to throw an error and it's not going to read the value. So now after we have received these two values from the users, we want to print it out to the program to ensure that we actually got these inputs from the user correctly and that the program has no issues in reading these values. So we can now say print f, say in a new line, the integer value supplied is, let's say /t, then we'll say %d, we also specify or indicate the specifier, and we'll say fixed, which is for fixed, and we terminate the program with a semicolon. Then we'll say print in a new line as well, We can do the copying this, but we want to demonstrate step by step what we're doing. So say print a new line, and we'll set the double value supplied is, say, percentage. Now instead of percentage %d, we say percentage %lf. Then we give comma, and we specify lab 05. As you can see, it's there, and we terminate the program with a semicolon. So to run this program right now, we just click on build, and we say yes. Good. So there are no errors and there are no warnings. So the next thing we want to do, we just click run. Now we specify 24, and we say 63.29. And when we hit enter, you can see the integer value is 24 and the double value supplied is 63. Now let's run this program again and do something different. Let's say we give 63.29. And as you can see, it didn't run the second command because there's an error with the code. Rather, it prints, specify the second number and ensure it's a double value. Then it said the integer number is 63 and the double value is the decimal. So now it broke the number into two. First of all, presented the integer number, then the remainder is now presented as a double number or float number, depending on what we are trying to print. So these are one of the reasons why when you are writing a code, you have to break it into simplest form. Imagine if we had specified in the code to accept these two numbers at the same time and print the output. If our code is having an issue, we would not be able to debug where this issue is from. And also, if you specify the number that is not related to the data type of the code or the program, then the first program will execute, but the rest of the program will terminate, and it's not going to, print the information accurately. Now, let's also run this. Let's say we say 24 integer, right? Now, second, we say 24. You see what's going to happen. You can see the first number, it accepts it, and the second number, it's printed it out and added zeros. Now you might be asking, why is this possible even when we supplied integer? In the various data type we described last week, we specified integer to be 16 bits and float to be 32 bits and double to be 64 bits. Now, integer is lesser than float, and float is lesser than double. So whenever you supply an integer value to a code, and the code is supposed to accept a float number, the code is going to pick that number automatically and convert it to float, because float is higher than integer. So also, if you supply a float number instead of a double number where the program accepts or expects you to insert a double number and you did not, since double is greater than float, it's going to pick that number from the user and convert it to a double number. However, this is also not a good practice when you do this way. And that is where conditional statement comes in. In the future, when we'll be presenting a snippet of code of what a conditional statement is, we'll be describing accepting these values. And if these values are really not integer type or the data type that was specified for the program to read by the programmer, then let the code throw the error or the exception message that has been defined or written in the program. It's not that complicated when it comes to programming. Like we rightly said, it's about you understanding the fundamentals. If you don't understand the fundamentals, then there is a big problem. You wouldn't be able to understand what you're writing. And even if you copy from a source code to replicate the data, which most people do, because when you go out there, you see a lot of tools. It's like everybody's writing the same pattern of code because they don't understand the fundamentals. So they are copying what the other person does. But once you understand the fundamentals, you understand that there are various ways where you can write this program instead of replicating the code out there. And not just that, it also makes you to be creative. So you can be able to like decide to write what you want and create the program that you desire to create without really copying what is out there. Because if you copy what is out there, then there is no change or there is nothing new. It's just like what everyone else is doing. These are just basics, and it's not really that deep. I mean, writing this simple basic code, you just have to understand the fundamentals. Now, let's do a simple arithmetic operation in C. We comment this out. Let's comment this out. So let's comment this out and let's write a new code. And let's now define a new program. We want to write a program that computes both arithmetic, subtraction, division, and multiplication. Now, there are various ways you can write this code, but doing that also, it's going to be something you would have to understand how to write it. We can decide to write it based on a function, but since we are not discussing about function right now and we have not gotten to that stage, let's just write it in a simple top-down approach. So let's say we want to compare between two values. One should be integer, and we call it fixit underscore 01. Remember, our variable name doesn't matter. We're just using this complex form, as you would be using this when you create your own private tools or code. And we'll say the other one to be, let's say a float. And let's say fixit 02. We want to read these numbers and compute the sum, the subtraction, the multiplication, and the division. So for us to do that, we also have to define various functions we want to perform. So we can say for sum to be float, or we can say double. Okay, let's just call it double since we are combining the integer and float, or we can also say float. So let's say float. We call it sum num. Then we say sub num. Now you might be asking, why didn't we define various data type? It's because we want to compute all the arithmetic operation into a float number. Now we say sum num, sub num, div num, mult num for multiplication, mult underscore num, and we terminate it with a semicolon. What this code is trying to say is that we are defining our first value. We're defining our first variable name, fixit underscore 01, which is an integer value data type. And the second one, fixit underscore 02, which is a float number data type. Then we want to compute the sum of these two numbers. We want to compute the subtraction of these two numbers. We also want to compute the div of these two numbers, and we want to compute the multiplication of these two numbers. So this is how simple it is. There is no complication. Because we understand what we want to do, we are able to break down this code to the simplest of form. If we do not understand what we are about to do, that's where the problem comes in. And like we said earlier on, it's always good to understand the fundamentals. Understanding the fundamentals should never be underestimated. If you do not understand the fundamentals, you would always have issues in writing code. So now, let's say this, let's make it single line comment. This reads the first value from the user. And let's say this reads the second value from the user. For those that do not know, these are single line comments, and you always use it whenever you know you're not making a long form of comment like we did earlier on here. There's a multi-line comments, and that's the reason why we use this. Then we say performs various arithmetic operations. Now we want to read this number from the user, right? So we say print f, say please do enter the first number. Yep, your program should be polite as possible because you want users to feel like they matter. Then we'll say scanf, and we'll say for the integer data type, we specify D, and we want to store this in the address allocated to fixit underscore 01, and we click semicolon to terminate the line code, and we click enter. So let's make this. Now let's go again. We'll say print f. We'll say we want to read kindly enter in a new line. Kindly enter the second number, which is a float value type, and we'll say /t, and we terminate the program with a semicolon. Then we want to scan the number that the user has inserted to the program. Now for float, we'll say %lf, and we comma, and we'll say end. We say fixit for float, and we terminate the program. Now this is where it comes. We can do this in two ways, by either doing their computation here, or we do the computation here first before printing it out here. Now let's do the first approach, which we want to do. So we can now say print f, we in a new line, we are going to print the various arithmetic operations. Skip it like this. Then we terminate the program with a semicolon. Then next we say sum num equals to fixit. Let's put bracket fixit plus fixit, and we put semicolon. Then we'll say print f %lf, comma, and we say sum num. Now we say the sum of this number r/t. So to not waste much of your time, let's just copy this and duplicate it here, and we say subnum, and we say minus. So this is for subtraction. And always remember to terminate your program with a semicolon. You do not want to have issues. So when you are writing a long program, you would always have issues where you need to debug. And if you are writing about 1,000,000 lines of code, you don't want to have that issues tracing back from the beginning of your code. So the next we want to do is divnum. So we call this to be what? Divnum. And we put \, for division, and we'll say divnum. Also go here, we'll say subnum. You have to be very careful as you don't want to print the wrong message. So you say the subtraction of these numbers, subtraction, and we'll say the division, and terminate the program with a semicolon. And we come down here to print the last one, and we'll say multiplication, and we call this mod num, right? Mod num, and we say mod num, right? Mod num, and we terminate the program with a semicolon. And the multiplication of these numbers. Good. So let's go back to our code and break this down. On line 7, we declared a variable named fix601, and we assign it to be an integer data type. On code line 9, we created a variable known as fix602 and assigned it a float data type. Then on code line 12 are the various arithmetic operations we want to perform in this program, and we assign them the various variable name as sumnum for summation or addition, subnum for subtraction, divnum for division, and modnum for multiplication. Then code line 15 requests the first number, which is fixit_01 from the user, and this number is read from the user using the scanf, and the specifier or the data type is integer, the reason why we have the %d, and fixit_01 is telling the program to look for the computer memory where there is fixit_01, and on this memory address store this number that was supplied by the user. So also for code line 18, we are specifying to read the number or the second number from the user, and also the number is a float number data type, the reason why we have the %lf, and the computer should also look for the memory address where there is fixit_02 and store this number in that memory address. Then code line 22, we are trying to say we are going to print the various arithmetic operation. Then on 24, we declared the sumnum, which is a variable name, and we say this sumnum to be equal to the computational value of fixit1 and fixit2. And after the computational value has been done, let it print this summation, and also the output should be in floats, the reason why we have the lf, and the variable name sumnum would pick this line number 24, whatever the mathematical operation or number that is assigned to this will be printed out here. So also goes for code line 29. We also did for subtraction between fixit1 and fixit2, and we call it, and we assign this value to subnum, and we're telling the program on line 31 to print the value subnum, which is also the difference between first fixit and the second fixit. Then for code line 34 is for the divnum, which is for division. We're also telling the program to do the same likewise. Between fixit1 and fixit2, divide these two numbers and print these divisions. Then since it's a float number, we specified the lf and the variable name divnum. For the modnum is the same thing, multiply these two numbers. Then after these numbers have been multiplied, print those numbers in the program, and at the end of the program, return 0, which is the end of the program. So now we have done this. Let's now build by first of all closing this by pressing 0, and we'll say build. Now we check if our debug has any errors. Okay, now it tells us lf, well, it's a double type. So let's just go back here and say %f since it's float. Yeah, for float numbers, you use %f, not lf. You go back here and where else do we have lf? I think we should not be having issues right now after we're done with this. Okay, let's run this again. Build. Yes, so it should be. Now you can see no errors, no warning, and it was very fast. This is another beautiful thing about building a sustainable code. If your code is very clean and properly outlined, then you wouldn't be having errors or delay in time compiling this code. So now let's run this code. Let's set the first number to be 24 and the second number to be 45.63. And now, okay, there is no beauty in this because we did not put it in a new line. These are part of the things about writing codes. You have to make it so clean that users can be able to read this. /n. Sorry about that, because we did copy and paste. Okay, now let's build again and let's run. So first program is 24 and let's say this is 12.3. Now say the sum of these numbers is 36.3 or 299 float, and subtraction is this, the division is this, the multiplication of these numbers is this. And you can see it only took us 8.257 seconds to execute this program. So this is one of the beauty about this is the beauty of understanding the fundamentals of a code or of a programming code. If you do not understand the fundamentals, you would not be able to write a clean, sustainable code. And not just that, it will also take you time to write this code. As you can see, this code did not take us 10 to 15 minutes, even though we are writing it slowly and explaining every lines of the code. And if you check right from here to 41, so probably we wrote over 35 or 34 lines of code within a short time. And because we're explaining this concept, that's the reason why it took this long. Usually, if I'm writing this code, it should not take me more than 2 or 3 minutes. Now, the second method we described is to make it more readable. Instead of having this here, right, we can just comment this out. Let's comment this out. Right? Now, we copy this operations. We come here. No need to rewrite this. Just cut and paste. To save more time and memory, you're going to understand what we did here now by the time we're done printing those codes. Now we cut this one too, and we paste it here, put a comma, and for the last one, we cut this one, and we put a semicolon. So this is exactly what we did here. As you can see now, our code took lesser lines, right? This is what we call clean code. Even though the other one is quite good, but it took more lines of code and also made it more difficult to debug. But this one, now we have defined this various data type and the variable name fixit1 and fixit2. And when I come here, I see this, I can understand that, okay, for float, you can also break it in line. It doesn't matter. As long as there's no semicolon, it will understand that the float is for the whole variable name defined. Now, if I come to this code right now and I look at this right now, I understand what this person is trying to do. Firstly, they declare the variable name fixit_01 and the data type is integer, and the second also for float. And not just that, they did the summation or the arithmetic computation of these two variables, which will be accepting data or values from the user. And here, they're accepting the first variable and the second variable. Then from line 28 to 36, they are just printing the entire arithmetic operation. So this is more clean compared to the first one we wrote. And also, not just that, when we look at the first code, if you understand what SQL injection is, you will understand the reason why you should have a prepared statement. What are prepared statements? You first of all prepare the statements before printing out the values. So even if users try to find a place in the code to inject, there will be no place to inject. This is more of a good practice compared to the first method we used. And not just that, when you write a code like this, it also makes it readable and much easier to debug. And as a programmer or as a cybersecurity personnel who is developing tools, you'll be writing a lot of tools, you'll be writing a lot of codes. You want to ensure that whatever tools or codes you're writing, everything is cool or awesome, in the sense that when somebody sees the code, they can find better ways to improve the code, like adding additional functionalities or making the code more sustainable by putting additional informations in the code. So sustainable means for a long period of time, people can also use the tool that you have created. Let's bring it back. Okay, let's do this. Div num. We just cut this here and we put it here. And let's run. Let's build. Okay. So as you can see here, instead of having multiple computational or arithmetic operation, we have assigned it to be a float and just do it in a single line. And we have to follow the top-down approach. Every programming code has to follow a sequential manner. If there are no sequential manner, then you'll be having errors with your code. So this is much better compared to the first method we used, whereby we're doing the calculation for each of the arithmetic operation. Because when you do such, it's very easy for a threat actor to conduct an SQL injection. If it's basically, if you're building a tool that has to do with payments and also require users to supply input, so users can, or threat actors can, find a way to, manipulate these inputs. But now that we have created a prepared statement here we are not receiving anything, or we are not doing any computational values. We've just done the one line code. We have prepared the various arithmetic operation. Then now we are printing this. And if we run the code, we'll still have the same thing. We'll say 24 and we'll say 56.79. And as you can see, it still did it. And now you can see it saved more time. Compared to the first method, it took about 8 seconds, right? And now it took only 7 seconds. So this is the beauty of, writing sustainable codes, or, making your codes more simple or easy to read. You want to make it in such a way that not just the future programmers that will access these codes will be able to, read those codes, but also the computers or the hardware components where these codes will be running. You don't want them to exhaust the memory of these various computer hardware. So we have finally come to an end of today's episode, and we hope you learned something new. If there are other ways you think we can make this content better, please drop your comments below and let us know. Also, do not forget to give the goodies, which are the like, by tapping the thumbs up button, subscribe by hitting the subscribe button, and click that notification bell to be the first to get notified when the next episode drops. Thanks for watching, and see you next week on another episode of Coding with Fixie Gateway Security. Bye for now.